Alright, this is 6-4, equations of circles. The equation of a circle will graph a circle on a coordinate plane. And I helped some people this last time using circles in their artworks on Desmos. So we know that we can graph a circle on a coordinate plane. And the way that we do that is using this equation, this baseline here. In order to graph a circle, we need to know two things about that circle, and both of these things are part of its definition. We need to know where the center of the circle is and what the radius of the circle is. So we need to know the center and the radius of the circle. Using those two things, we can fill in kind of the blanks here. In the circle, we have the radius squared in the equation, the radius squared equals x minus h squared plus y minus k squared. And the h and the k come from the center of the circle. Let's label that. So here's the radius, and it's the radius squared too. So we might see some where it doesn't have a squared on there, and instead it's replaced with just, oh my goodness, I can't spell and talk at the same time. Radius. So sometimes the radius will be the actual squared number. So for example, you might have 4 equals, and you have to know that 4 is really 2 squared, so the radius is 2. That's the radius, and then these two things combined are the center. The other thing that I will say is that h and k in the equation of a circle are both preceded with this negative sign. So it always looks like the negative sign from what it really is. So we kind of have to switch the signs in our head in order to tell what the actual center is. And we'll see some examples of that. So the radius and the center, everything else stays the same. So the x minus, the y minus, the squareds, those all stay the same. What we're doing is putting in the center and the radius in these practice problems. We are just wanting to find the center and the radius, and then write an equation for the circle. So this circle has a center at, and I apologize for the skipped numbers here, there's a 1 in between there. So that radius is at 2, 1. I'm sorry, the center is at 2, 1, and the radius is indicated there that it's 5. So the center of the circle, hang on, so we have x minus, and then 2 is the x coordinate. It's really convenient that the x coordinate goes with the x and the y coordinate with the y, just something to notice. Then y minus 1 squared, and then the radius goes out here squared. So we have radius, I have to check how I highlighted this, h and k. There you go, perfect. So this is the equation of the circle. We don't have to do anything else besides just stick in that radius amount and the center. So let's try this one. We have a center at 2, 2, and a radius, it's not indicated here, but the radius goes from 2 to 6. Let me get mine, there you go. From 2 to 6. So we have 2, 3, 4, 5, 6. This length is a length of 4. We have to be kind of careful because of the way that these graphs are numbered, because this is numbered by 2, so it looks like it's only 2, but this is a radius of 4. So we have the radius of 4, so 4 squared equals, and then x minus 2 from the center, plus y minus 2, also from the center. So we got 2 from there, that 2 there, and this 4 from how long the radius is. Perfect, that's the equation of that circle. I'll move it over because it's not in the middle. Great, let's try a new one. On this back side, we are still writing the equation of the circle. This circle, the center is at 1, 5, it looks like. 1, 5. And then the radius, so the radius the way that it's drawn is diagonal, and I can't really tell how long that diagonal is. I can tell that the radius is going to be like 2 and a little bit, but to find out exactly how long that radius is, we can do a little bit of Pythagorean theorem, which I know is something you know because I've taught you that. So we make a triangle using that diagonal radius. So we're going to call this r because we want to figure out what the radius is. And then this distance is a distance of 2, and this distance is 1. So we have a triangle, a right triangle, with the two legs being 2 and 1, and we are looking for the hypotenuse, which we've labeled r because it's the radius. So really quickly, I'm going to do that problem here. So we know that r squared is going to equal 2 squared plus 1 squared. 2 squared is 4, and 1 squared is 1, which makes that 5. Then to solve for r, we're going to have to square root both sides, which gives us that 2 and a little bit number that we were guessing it might be. So the square root of 5, I'm not going to actually write the value of the square root of 5. I'm going to just leave this, and you'll see why in a second. But this is going to be my radius, and then I know my center is 1, 5. So my equation, and I'm going to write it down here, my equation will be the radius squared, so the square root of 5 squared. You might be noticing something there, and just hang on to that for a second. Then we have x minus 1 from the x coordinate plus y minus 5 squared from the y coordinate. The square root of 5 squared, the square root and the squared like undo each other. So we can simplify this to just say that that's 5. The square root of 5 squared is 5. So even though we don't like know the radius exactly because we don't know what the square root of 5 is, we can still write the equation of this circle really accurately because the equation of the circle has the radius squared in there, which is very easy when we have a square root going on. So that's the radius of that circle. Let's try this one. So this one says the circle centered at negative 2, 10, which goes through 4, 6. Okay, so this is the center of the circle, and this is a point that it goes through. So theoretically, it's kind of this giant circle that we can't see a lot of. And the most important thing is that we know where the center is. The center is at negative 2, 10. And then the other most important thing is that we can tell what the radius is going to have to be here. By doing the same thing that we did last time, because it's diagonal, we don't really know exactly how long that is unless we do some Pythagorean theorem. So there's my imaginary triangle. This side of the imaginary triangle is 4 long. 1, 2, 3, 4. And this side is 1, 2, 3, 4, 5, 6 long. Double checking that. And then we are wondering what the radius is. So same Pythagorean theorem thing. We know that r squared is going to equal 4 squared plus 6 squared. So that's 16 plus 36, which makes 52. So r must be the square root of 52. So the radius is the square root of 52. Not super sure where exactly that is, but that's okay because all we're doing is trying to write the equation of this circle. So we have the center, and we also have the radius. Center at negative 2, 10. That's the wrong color. And the radius at square root of 52. So the square root of 52 squared equals x minus And this one's a negative 2, so x minus negative 2 is really positive 2. Plus y minus 10 squared. And this, hang on, this came from x coordinate, this is the y coordinate, this is the radius. Then we have the square root squared thing going on again, so we can simplify this to just be 52 on the outside. The mathematics of that is not super important. And what I mean by that is just that you could leave it as the square root of 52 squared and it would still be a valid equation. We just are conveniently, we can simplify a little bit and it's just convenient. So I'm not trying to grill this into your head that the square root of 52 squared is 52. Like that, if you put on the test the radius here as the square root of 52 squared, I would give you full points. Like that's not super important. I just want to point out to you that it's possible to simplify that and not have to get a decimal for this, just because it simplifies. So, okay, there's that. The next thing that we need to talk about is finding the center using completing the square. So, this is a skill that you're going to have to pull out of a long time ago in the past. So I pulled up in this other page when we learned how to complete the square. So we're going to just review this really quickly because it's going to help us a lot. The idea behind this is that sometimes the equations of the circles looks like this, which is a nightmare, right? There's no, it is this same thing. This will still graph a circle, but it's not in the same form, and it's not in any useful form for us. Like we can't tell where the radius is and what the center is at all. By completing the square, we can change this form into this. So completing the square involves making complete squares. And so we first talked about how to make perfect squares here. And the way that we did it was we would take the middle value, which is all that we started with, and then we would divide by 2 to get this value that's in the factored form. And then that number squared to the power of 2 will give you the last number in the perfect square. So it was a divide by 2 squared pattern here. And so then we used that to create perfect squares within quadratics, right? So we had this quadratic, and what we first did was move over the 5, and then put just the 8x and the x squared in parentheses. So at this point, we didn't know what this number was or what this number was. That's all we had right there. And then from this point, we took the 8 and then we divided by 2 to get the 4 to put it in this factored form down here. And then we squared 4 to get this 16, which I've scribbled out. We got 16 there. When we added 16 in order to make this a perfect square, but in order to keep the balance, in order to not change what our equation was, we took away 16 as well. So that's why it says keep the balance, because we're trying to balance out our equation so that we're not changing it somewhere along the way. And then we already have the factored form. We already wrote this factored form from this process. This number comes from just combining this positive 5 and this negative 16. The positive 5 came from the original equation, and the negative 16 came from keeping the balance. And this is our vertex form of a quadratic. So we're going to use a similar process here to complete the square with circle equations. The first step, and the steps are all in here in case you get stuck. The first step is to separate the x's and the y's from each other. Because we have sort of two, we're going to have to complete the square twice here. Because we have both an x quadratic and a y quadratic to think about. And so I'm going to move the negative 16 and the 4x squared to be next to each other. So I have 4x squared minus 16x. There's that. And then I'm going to move the 4y and the negative 24y to be over here, minus 24y, and then I'll just leave the 48 by itself. These problems you need a lot of horizontal room, you will find, equals 0. So now I've done no math here, I've just moved the x's together and the y's together. And then I've put parentheses around them just as sort of placeholders so that I can tell what's happening here. So I have the x complete the square over here, and the y complete the square over here. So you might remember from completing the square that if you have a number in the front of the equation, and I'm double checking here. Okay, we're gonna back up a step. Sorry, the day that I record this is before I teach this lesson to anyone else, so you guys get to be my guinea pigs. The first thing that we're gonna do on this, just to make our lives easier, I don't know if you noticed this, but every one of these terms can be divided by 4, including 48. And so what we're gonna do to make our lives easier, if that ever happens, just divide everything by 4. Because if we divide both sides by 4, we don't change really anything about this equation, right? The 0 divided by 4 is still 0. And then we just got rid of a bunch of annoying leading coefficients here. So I'm going to have to rewrite this all anyway. I might as well erase it. It's the worst. So 4x squared is just x squared now. And 16x is just minus 4x. I'll draw arrows to hopefully track where I'm keeping these things. And then the 4y squared is now just y squared, and the minus 24y is now just minus 6y. And then the 48 is 12. And now we have, again, I'll highlight these. We'll have the y quadratic and the x quadratic here. So our next step is to complete the square, and I do that by, I first sort of write my factored form down here. I know I'm going to have x something squared, and I'm also going to have a y something squared. And this plus 12 is going to stay, and we'll see later how that plays into things. But we're going to follow the same process. We're going to divide by 2 to get that number, and then square that number to get positive 4. And I'm actually going to write that with a different color so we can keep track of what we're doing. How much we're essentially changing the original equation, that's important. So I'm going to do the same process here. I'm going to divide by 2, which makes negative 3, and then square that to make positive 9. And then just like when we completed the square, we're going to have to take away those things as well. And that will happen to the 12 out there. And so we're going to do 12 minus 4 minus 9, 9, 10, 11, 12, 13. So that makes negative 1. I wonder if I should keep that as orange. I'll just put that here. So we combined all of this to make negative 1. 12 minus 13 makes negative 1. And then we still have that equals 0. So we're super close to standard form of the equation of a circle. Because we have x minus 2 squared, that gives us the center coordinate of 2, right? Then we have the y minus 3 squared, which gives us the y coordinate of the center of 3. And then we have minus 1 equals 0. And normally we have the radius on the other side, so I'm just going to add this extra number that we have on the end to the other side so that we now have equals 1. Now the radius here is always squared. And here it doesn't super matter because it's 1. 1 squared is the same thing as 1. But it's important that you know that that number is the radius squared, not just the radius. So 1 is the same thing as 1 squared, so we know that the radius then is 1. And so through that process, we got the center of the circle is 2, 3, and the radius is 1. I know these are big problems, and they're hard to keep track of all the moving parts. So we're going to practice a couple of times, and hopefully through a little bit of repetition, you'll be able to keep track of what's happening better. I think that's all I'm going to say about this one. So we're going to keep going. I might highlight a little bit. These are the y's and the x's, just so you can track sort of where those are going. And then outside here we have the plus 12, which became this, and then we moved it over to the other side. Okay, so let's try this on number 1. I've left a lot of space, so hopefully you have space to write this. The first step is to check if everything is divisible by one thing or not. This one isn't divisible by a single number, which is fine. We just don't divide both sides by anything at this point. So then we just need to combine, or we need to gather together our x's, minus 2x, and our y's, plus 4y, space, and then we still have this minus 20 equals 0. And then we can write down here our factored forms. Still have that minus 20. Actually, we'll change that in a second, so we're going to not write that. So we divide by 2 to get minus 1, and then square it to get positive 1, and I'll write that in a different color, positive 1. And then same thing over here, we divide by 2, which makes 2, and then square it to get 4. So we also have to take away 1 and take away 4 in order to keep the balance. So outside here we have negative 20 minus 1 minus 4, which makes negative 25. And then we just need to add 25 to both sides so that we have the radius on the correct side. And then we get this final form, standard form, I should say, of the equation of a circle. X minus 1 squared, y plus 2 squared equals 25. Also known as 5 squared. And I will rewrite this again, or rather copy and paste it again, so that we can see the final equation of a circle here, where the radius is 5, and then we have the x and the y coordinate there. So the center of this circle is at positive 1, remember the sign switch, positive 1, negative 2, and the radius is 5. I don't need parentheses. Good deal. And we're going to graph that in a second, but I will keep going and do number 2 here first, and then we'll finish by graphing these equations. First we check if everything's divisible by one number, and this one it is. All these numbers are divisible by 3. So I'm going to start out by just dividing everything by 3, both sides. So that we have x squared plus y squared plus 24 is 8. 8x minus, 6 times 3 makes 18, minus 11 equals 0. And now we can gather together our x's, plus 8x, and then our y's, and then minus 11 is out there, we still have equals 0. I'm going to get my factored forms ready down here so I have somewhere to put numbers. there's a plus in between there, and then minus 11. Actually, again, we're not going to write that because that one changes. So we divide by 2 to get positive 4, and then we square it to get 16. Then we divide by 2, we get negative 3, and square it, we get positive 9. And so we need to take away 16 and take away 9 out there, which gives us negative 11 minus 25 is negative 36. And then last step, we just need to add the 36 over so that it's on the correct side, and we get x plus, I almost thought that was a y because of my handwriting, sorry. X plus 4 squared plus y minus 3 squared equals 36, also known as 6 squared. So we have the radius here, the x and y coordinates there. So the center of this circle is at negative 4, positive 3, and the radius is at 6. Actually, that's not what I want to box. This is what I want to box. There we go. Beautiful. So let's graph these. So this one has a center at 1, negative 2. So over 1, down 2. That's the center of our circle. And a radius of 5. So from that circle, I can just count. The best way to do this is count 5 in all directions and then just connect those dots. So I'm counting 1, 2, 3, 4, 5 up. And then 1, 2, 3, 4, 5 over. And then 1, 2, 3, 4, 5 left. And then same thing down. So just so you know what I'm doing, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then you do your best to draw a circle. My technology fixes bad circles. We'll see if it can do this one. Ooh, might be too small, which I can also fix. So circles are not the easiest thing to draw. I realize that, so don't worry if yours is bad. Number 2 here, we have the center at negative 4, 3. So I'm going to go back 4, up 3. That's my center. And from that point, I'm going to go in all directions 6. It's a big circle. 2, 3, 4, 6. And then 1, 2, 3, 4, 5, 6. Ooh, that one's close to being off. Ooh. Beautiful. Technology is great. Okay, so those are my 2 circles. I might draw in here just so for posterity's sake so we can tell that this is 5 and that this is 6. Okay, that's all I have for you, and I know that this process is a little bit wild, so if you need these as examples, please have them up as you're working on your homework, because MathSpace will require you to do this kind of thing. So, and I think it will want steps. And let me know if you have questions.